I'm Patrick Michel. I am with Professor Makoto Yoshikawa from JAXA, and we are going to talk about Hayabusa2.
Yes, so it is a sample mission return. Now tell us a bit more about the samples.
Yes, so Hayabusa2 spacecraft went to asteroid Ryugu and get a sample from there. And yes, this is one of the biggest samples, real-size samples, very black. And now many scientists are analyzing this, and they already found some amino acid or other elements.
Yeah, so this is absolutely amazing because these are the first samples from a carbonaceous-rich type asteroid that were returned to Earth. So this is the first time we can analyze in the laboratory these little samples and determine the actual composition of these very dark type objects. So this is one of the biggest sample, and this is the same one multiplied by 10 in size, just to show the characteristics and the structure. So we analyze the structural properties of these samples, and basically the shape and the morphology is about the same as the shape and morphology of bigger boulders on Ryugu. So we believe that these samples, although we just got back a small amount, but very big, 5 grams, bigger than what we hoped for, they are representative of the material of Ryugu. And what we find is that this is the most primitive material that we ever return from, that we have in the lab, basically, because it contains the original composition of the solar nebula in which the solar system formed. And it is very, very, very old, very, very old. And we don't have any material on Earth which is as old and as preserved, as pristine as this sample. The closest analog on Earth are what we call meteorites, which are carbonaceous type. There is a class of meteorites, we call them the CI meteorites, and they have the same composition as this material. And they are the oldest, the most primitive meteorite we have. So we are really now making the connection between some meteorites and some very primitive asteroids. And as Professor Yoshikawa said, we detected amino acids. They also contain water, so we can make the link between these samples and the emergence of life on Earth, and check whether these scenarios that say that maybe life emerged on Earth thanks to asteroids impacting the Earth at the end of the formation of the Earth, and maybe bringing all the elements that made life emerge. So we are trying to verify that with these samples. So even though there was only 5 grams coming back, it seems small for the public. It's amazing success for the mission and also for the cosmochemists, who are the ones who analyze the samples, because they can do a lot of things with just 5 grams. So it's absolutely spectacular. And this is one of the samples, real samples, that are exposed here.